Mercury's sunrise is characterized by a harsh, blue-tinged light due to its lack of atmosphere. The absence of an atmosphere on Mercury results in a sharp contrast between light and shadow. The sun appears to crawl slowly over Mercury's landscape, a stark contrast to Earth's rapid dawn. Mercury's desolate landscape is bathed in the sun's harsh light, creating a stark and alien environment. Venus's sunrise is characterized by a subtle brightening effect due to its dense atmosphere. The thick, sulfuric clouds of Venus obscure the sun, resulting in a dim and murky appearance. The sunrise on Venus lacks the sharp, distinct appearance observed on Earth due to atmospheric conditions. The density of Venus's atmosphere significantly affects the visibility and intensity of sunlight. The diffuse brightening at sunrise on Venus is a result of light scattering within the planet's atmosphere. Earth's sunrise is a vibrant, orange blaze painting the sky. Sunrise is a dynamic event caused by atmospheric scattering. Atmospheric scattering causes the familiar orange color of sunrise. The Earth's rotation creates the daily sunrise event. Sunrise on Mars presents a cold, blue sun appearing over the horizon. The thin Martian atmosphere causes sunrises to appear muted and distant. Martian sunrises lack the warmth and intensity observed on Earth due to atmospheric differences. The color of the sun on Mars appears blue due to the scattering of light by the thin atmosphere. Dust particles in the Martian atmosphere contribute to the unique color and appearance of the sunrise. Jupiter's sunrise is characterized by a gradual color transition. The atmosphere consists of swirling bands of ammonia clouds. The lower atmosphere exhibits a deep indigo hue. The upper atmosphere transitions to a lighter, stormy blue. Jupiter lacks a solid surface, consisting entirely of gas and liquid. The sunrise effect is a result of light scattering within the atmosphere. Saturn's sunrise, though fainter, shares similarities with Jupiter's. Saturn's rings cast long, ethereal shadows across the planet's cloud tops during sunrise. The shadows cast by Saturn's rings add a unique visual element to the planet's atmospheric phenomena. The faintness of Saturn's sunrise contrasts with the distinct shadows cast by its rings. The ethereal shadows enhance the visual complexity of Saturn's atmospheric landscape. Saturn's sunrise provides a unique perspective on the planet's ring system and atmospheric dynamics. Uranus appears as a pale cyan disk due to its atmospheric composition and distance from the sun. The sunrise on Uranus is a subtle brightening of the faint light, a consequence of its extreme distance from the sun. The extreme distance from the sun results in minimal solar illumination on Uranus. The faint light on Uranus is due to the limited amount of solar radiation reaching the planet. The subtle brightening of sunrise on Uranus is barely perceptible due to the low light levels. Neptune's sunrise is characterized by a slow, almost imperceptible shift in light. The dim, deep sapphire blue light highlights Neptune's remote location in the solar system. The glacial pace of sunrise on Neptune reflects its long orbital period and slow rotational speed. Sunrise on Neptune is a gradual transition, rather than a sudden burst of light. Planetary sunrises exhibit significant variations in color due to differing atmospheric compositions. Sunrise intensity varies across planets, influenced by distance from the sun and atmospheric density. The speed of sunrise differs due to planetary rotation rates. Atmospheric scattering and absorption affect the perceived color of sunrises. The composition of a planet's atmosphere dramatically alters the sunrise's visual characteristics. Mercury's lack of a substantial atmosphere results in extreme temperature variations. The absence of an atmosphere on Mercury leads to a direct, unfiltered view of the sun. Without an atmosphere, Mercury experiences drastic temperature changes between day and night. The surface of Mercury is exposed to unfiltered solar radiation due to the absence of an atmospheric layer. Mercury's thin exosphere provides negligible insulation, contributing to extreme surface temperatures. The lack of atmospheric pressure on Mercury means no protection from solar winds and micrometeoroids. Venus's atmosphere is predominantly composed of carbon dioxide and sulfuric acid. The dense atmosphere of Venus traps heat, leading to extremely high surface temperatures. Sunlight is scattered by Venus's atmosphere, resulting in a diffused and dim appearance. The combination of atmospheric composition and density creates a unique environment on Venus. The scattering of sunlight in Venus's atmosphere results in a dim and diffuse sunrise. The density of Venus's atmosphere contributes significantly to its high surface pressure. Earth's atmosphere contains a mixture of nitrogen, oxygen, and water vapor. The atmosphere scatters blue light more effectively than other colors. Scattering of blue light is why the sky appears blue during the day. At sunrise, sunlight travels through more of the atmosphere. The increased atmospheric path filters out blue light, leaving orange and red hues. This effect causes the vibrant orange and red colors observed during sunrise. Mars has a thin atmosphere. The Martian atmosphere is rich in iron oxide dust. Iron oxide dust absorbs blue light. The absorption of blue light results in a cold, blue-tinged sunrise on Mars. The thin atmosphere and dust composition contribute to the unique Martian sky color. The Martian atmosphere's properties affect light scattering and temperature regulation. Gas giants, including Jupiter, Saturn, Uranus, and Neptune, feature thick atmospheres. These atmospheres are primarily composed of hydrogen and helium. Trace amounts of other elements, such as ammonia and methane, are also present. The composition of these trace elements affects the color and intensity of sunrises on these planets. Variations in atmospheric composition lead to diverse coloration across different gas giants. Planetary distance from the Sun significantly affects the intensity of sunlight received. Planets farther from the Sun experience fainter sunrises due to reduced solar radiation. The duration of sunrise also increases with greater planetary distance from the Sun. The inverse square law dictates that light intensity decreases proportionally to the square of the distance from the Sun. The solar system consists of diverse planets orbiting the Sun at varying distances. Planetary conditions, including atmospheric composition and surface features, vary significantly across the solar system. Sunrise on each planet is influenced by its axial tilt, rotation speed, and distance from the Sun. The relative positions of the planets change continuously as they orbit the Sun. The diversity of planetary conditions affects the appearance and frequency of sunrises across the solar system.